Just wanted to provide another update on the management zone creation in Engage, and also what are some simple steps on going down the journey of utilizing the protein data along with the yield data to then inform your recommendation sort of pathway. There are a number of different calculations you can do, or your agronomist might default to utilizing for your nitrogen recommendations, and we still recommend doing soil testing to validate what your base starting point is of nitrogen in your soils. But really want to step through when we can start interpreting some of this protein data. What does it mean for stepping up a yield increase and also that protein increase as well, so we can maximize that yield protein relationship? So yes, you can create management zones in a number of different software types, and we've been through how we can create those zones within the CNHI portals, like AFS, PLM Connect, FarmWorks, and SMS, like desktop software, but really pushing forward on utilizing what we've learned out of working with the CNH platforms, Operations Center, FarmWorks, desktop software, working manually with a number of growers. We've really tried to get a lot of these friction points out by utilizing the Engage app, which we've compiled into there. We do have some APIs coming into the system, so we're working with the Trimble, Topcon, AGCO, and Class APIs. So guys running those machines in the interim, we're still utilizing, say, a CNHI or Operations Center account and working through from there. And also a reminder for pairing your accounts is we do recommend to pair with whatever system you're using for your spreader spraying seeding operation. So whatever controllers you're using there, it's simpler to work in with those formats of where we're sending that data to, rather than just pairing with what harvester platform you're running. So just something to keep in mind, and we can work through some of these steps. Please reach out, shoot us an email at support@cropscanag.com if you do have any queries or you're running into any roadblocks on getting your data to come into Engage. So if you remember back, we've really sort of based a lot of our messaging on trying to simplify sort of where protein can be utilized for that yield response, and we're not just chasing protein for protein's sake. Yes, there are opportunities to time your nitrogen just to increase protein, but really we want to be supporting you with this data to be able to make more informed decisions around which areas could have gone harder, which areas could have been backed off, and redistribute the existing fertilizer spend, where you might have more confidence to apply more nitrogen, and where you've got confidence to back off and not over apply in certain zones as well. So fundamentally, it all boils back to sort of that agronomy 101 component of that nitrogen response curve in relation to yield and protein. So here we've got that nitrogen response curve. As we apply more nitrogen, we'll increase protein and increase yield. So that's really the fundamentals of that process, and that's what we've got to keep boiling it back to. When we look at individual systems in different areas on different soil types, we've got to work out what this curve looks like for you. So everyone's got different yield targets, different protein targets. What works for the sweet spot of ideal wheat production might not be the best fit economically for you in your zone and the risk involved with the rainfall pattern you're farming under. So this is what we're trying to fundamentally boil it down to. So what does that look like, and what does that curve mean when the harvest is done? So just wanted to deep dive into this slide a little bit more, because there's a lot of information sitting here that can really help you simply go on a journey of, say, what some of these numbers might mean to you, and what does it mean for your recommendations or prescription numbers that you might be looking to manipulate or play with this season. So again, we've got this yield protein relationship. So this is essentially that graph we just saw before with the nitrogen response curve. This is the actual results curve, or results matrix, of what it looks like of how much nitrogen. So this is units of nitrogen out here in the table that is removed when we've harvested a X volume crop with a certain protein content. So whatever the yield, whatever the protein, we can then look at up that on the matrix. So the reason why we have so much confidence in how that nitrogen is driving that protein is the CropScan grain analyzer is essentially measuring those nitrogen bonds that make up protein in the grain, which for wheat is 17.5%. Of the protein is made up of nitrogen. So it is a major component of that protein. And then sulfur as well is 3.5% of that protein in wheat. So that's where we can get these really good relationships coming out of this data. Then once we step through saying, well, what does it look like for some of these yields in this area, and where are we trying to take them? So if we say pick a spot on the map, we're trying to look at, we had a 9% protein grain, and a lot of the time growers are trying to get it to that 10 to 11.5. So 10.5 to 11.5 is really common across a number of Australian systems for their grain protein content. In the US, they're probably more in that 12 to 13 sort of range for what works for them. But if we look at this example that we're circling here, is saying, how do we start getting grain that was coming in at 2 tonnes at 9%? And what would it have mean to have harvested 2.5 tonnes, 2.5, 3 tonnes at 10%? And this is how we can start utilizing, like reverse engineering some of these numbers to say, what should we be applying in these zones, and how much more N availability do these areas need? So basically, as we shift across to the right here, you'll see we change sort of around that 2 to 3 units of nitrogen are removed extra as we move up that protein grade. So going from that 31.5 to 35, so we've jumped up, and that's pretty common, even seen anecdotally across the field. When you are trying to change protein late in the season, typically sort of that nitrogen response to protein changes is around that 6 to 8 units of nitrogen to shuffle it up a grade, remembering there's inefficiencies with that. So a lot of the time we'll default to work on, say, 50% efficiency of your applied nitrogen. So when we're applying those extra units late in the season, that's where we do get that bump of that protein directly across to the right. But what we want to be doing is applying it at a time when we can get that bump to the right, but also that bump up the yield curve as well. So what does that start looking like? So if we looked at a whole ton change, then you'd be looking at around, going across this, depending on what your protein grade is, each ton is removing between sort of around that 14, 15 kilos per ton of nitrogen, up to 20, 22+%, depending on how high protein you're removing. And this is based on that 17.5% calculation of that grain protein. So if we are going up a full ton, we'll be looking at budgeting an extra 14 to 22 units to increase. It would be required just by default to be increasing that yield based on what's required to be removed. What we're typically seeing for each percentage point of protein that we're trying to increase, so if we're trying to go from 9.5 to 10.5% protein, we're sort of seeing a 300 to 600 kilo yield response. So depending on where your zone is and that sort of thing, we're seeing variations around that. But if we were looking in that range, that's sort of what we would be taking, essentially that 300 to 600 kilo percentage out of this 14 to 22 units. So in this example, say if we did get a 600 kilo increase and we wanted to increase that protein as well, we would be looking at 9 units would be required for a yield increase, and then shuffle across the x-axis, would be then 3 units would be required for that protein bump, which is around that 12 units of nitrogen, or around that 30 kilos of urea for that percentage point change. And really that's stripping it back on what we think that yield target is, and what we're trying to chase that protein change on. So you can look at this sort of table within your own system as well, but just wanted to strip it back to the raw numbers around that, of where some of the fundamental prescription pieces are coming from. and that it's sort of driven by the kind of actual numbers that have been removed in the background. Of course, in different areas, different soil types, different rainfall patterns, the strategy around how you actually get that to make that happen does vary. On can you get away with it all up front in the lower rainfall areas, or do you need to go on a more of a drip feed strategy or multiple pass strategy to be able to make sure you're timing that nitrogen availability for those key growth stages, to make sure you're delivering a yield response as well as that protein increase as well. So just want to give you something to think about there, just around some of those raw figures. More than happy for you to get in contact as well, just to bounce some other ideas and strategies around. But and like I say, there are a number of different calculations you can use, but fundamentally it still kind of boils back down to the raw numbers that are sitting in the background that drive a lot of those calculations. They end up having factors in them that are more environmentally considerate for where you're producing, and and looking at that inefficiency element as well. So as we go forward, as we step back into the Engage app, when we're thinking about this, is saying what raw data layer are we going to utilize when we're looking in the app, so we can have that yield, protein, we can have the analyzed layers as well, which all are generated out of the Engage app once we do import the yield. And then we create those management zones, work out what we're going to put in the different areas, and then zone that up as that prescription. And then we can push it out from there. So really trying to strip it down to as simpler process as possible. And remembering you don't have to do every field every year, and you're not going to shoot the lights out in your first year either. It's utilizing the data, going on the journey of utilizing the information, acting on where that variation is sitting. And again, quite common, and we'll see between 20 to 50 kilos difference in deep ends based on different yield protein removals in the different zones of the field. So nothing else, if you are doing some ground truthing this year, is utilize some of those protein or protein yield correlation maps for strategically placing your soil tests and see what you learn out of it in your area. So again, just want to give you these links of some of the main portals to go to link this all through. And yeah, thanks for tuning in. And again, please reach out to us if you have any questions around setting up your account, getting the data to flow in, or creating prescriptions and sending them back and utilizing them. So thanks for your time.